Good morning. Try again, good morning. Good morning. I'm Mark. I'm part of the district team here at Leamington Scouts, and it's a real pleasure to be there. Can you see again? Hello, Mark.
Hello, Mark.
Oh, brilliant. So we are here today to talk to the International Space Station, which is brilliant. Who's excited? Hey! Excellent. It's going to live up to those expectations. But also, it should be inspiring. There are some amazing people you're going to meet today who have done some amazing things in their lives. And I want you to take from that you can do anything you want to do. And Scouts is here to help you do that. So it's going to be a brilliant morning. Looking forward to the next hour. I need to start quickly by letting you know what happens if there's an emergency. There's a lot of technology here. Something could happen, shouldn't happen. If it does, we have a door at the side, a door at the back. We will calmly take you out in your groups. We'll walk around the side to a field behind here and we'll look after you. But if that happens, we'll let you know. Assume it's not going to happen. But I have to start with some thank yous. You do not turn up on a day like this with things just happening. I came yesterday and it was a very busy place, but a lot of people put a lot of hard effort, but particularly some sponsors. You'll see here ARISS, the Amateur Radio International Space Station, on the space station. They have put a phenomenal amount of work into providing the kit and the people and the contact, which you'll see here, linking us up to the space station. They are amazing people doing amazing work, and we'd like to thank them. Just thank them now. Applause. Yay! We also have to thank the venue. Hatton Adventure World have given us this space, which is an amazing space. I remember this place from many years ago where there were just guinea pigs and some goats, and it's come a long way. And it's a brilliant place, and they've done a great job in hosting us. So thank you, Hatton Adventure World. We also have an organisation called Eclipse who have provide amazing equipment to many places, setting up venues for audiovisual experiences, and they've managed to lend us some kit on top of all their other commitments, whether that's the screens, the systems, the screen that's live streamed across to our Hatton campsite. They're in many places to do many things, but without them and without them lending us Gavin for amazing amounts of time, we wouldn't be here today. So thank you, Eclipse. And we also have a couple more people. These things don't come cheap. People have to work hard to make these things happen, and we have had a couple of sponsors who've done a lot for us. We have Jaguar Land Rover. Many of us have connections to Jaguar Land Rover, personal, family connections. They're deep parts of our community, and really pleased that they've helped us to get to this point today. So thank you, Jaguar Land Rover. And also our friends at Leamington Round Table. Leamington Round Table are, again, regular sponsors of the work we do, and we wouldn't do some hard things to do without Leamington Round Table. So again, thank you, Leamington Round Table. So my challenge is to keep to time, which is always a challenge for me. But I guess for me, the key thing today is we're going to have an opportunity to speak or listen to a number of people talking about space. We're going to have a video link or a recorded video from someone who deals with space quite a lot in their world and is going to tell us a bit about space. We can have someone live talking about space. We're going to have young people talking about space. We're going to have astronauts talking about space while people ask questions over here. And then we'll ask even more questions, and eventually we'll finish. But we've got an hour to fill of exciting stuff. So I think we're nearly there. I think we're at the point where we can start to think about the next step, which is the video. Are we ready for the video, do you think? Yeah? Do you want to see a video? Right, before we have the video, let me tell you who you're going to see. You're going to see Susie Imber. Susie Imber is a professor of space physics, which is impressive. She works at the University of Leicester, but she's also a British planetary scientist specialising in space weather. Not only that, she was the winner of the 2017 BBC Two television programme, Astronauts Do You Have What It Takes? Which I think it means she's on call-up for the European Space Programme if needed. So that's an amazing place to be. And in her spare time, she climbs high-altitude mountains across multiple continents, Himalayas, Andes, Alaska, you name it. So she's a brilliant inspiration to us all. She would love to have been here, but the diaries and the connections are complex, shall we say. And I think what we've tried to do is bring her into the event in a way that makes sense. We have a video of Susie who's going to tell us about, I guess, her experience of space and what that might mean to us. Go.
Hello everyone, I'm so sorry I can't be with you today. My name is Susie Imber, I'm a planetary scientist, and I'm going to tell you a little bit about my job and my career, the things I love to do in my spare time, and training to be an astronaut. So, let's start out with my job. I am a research scientist and I work at the University of Leicester, and my area of expertise is trying to understand how the sun interacts with the planets in our solar system. So I'm sure many of you out there have a favourite planet. My favourite planet is Mercury. And that's because I was working at NASA when their spacecraft got to the planet Mercury, the first spacecraft to ever go to Mercury and orbit the planet. And so in that time, I learned so much about Mercury and its environment that I decided to specialise in studying Mercury. Probably that wasn't many of your favourite planets, but it is my favourite planet. So I spent a lot of time working in the UK, but also abroad. I work in the US at the University of Michigan and at NASA, as well as with my colleagues in Europe. But I also get to do a lot of travel, or I did before all of this happened. And so in the top left, you can see a picture of me standing underneath a massive radar dish there. I'm on a group of islands called Svalbard, way north of Norway up in the Arctic Circle. Someone has to run that radar all the time. And that was my job for 3 months. The problem was, I went there at a time when the amount of daylight in a day was going down and down and down until one day the sun did not come up. And I was there for 2 months in complete darkness. So that picture of me was taken before the sun disappeared. On that island were 100 people and 3,000 polar bears. So it was a great adventure to live there for a few months running that radar. And that's just one of the super exciting things you get to do if you're a scientist. So the mission I'm working on at the moment is called Bepi-Colombo. It's a European Space Agency mission on its way to Mercury now. So it launched 1.5 years ago, and it will arrive in December 2025. It's a 7-year journey to Mercury. And the reason I'm excited about it is because in the slide there, you can see a picture of an instrument. We built that instrument at my university in Leicester, and it's on that spacecraft, and it's going to tell us for the first time what the planet Mercury is made of. So keep your eyes open in the news for updates on the Bepi-Colombo mission. You might even see me talking about it. The other thing that I've always loved to do is sport. I'm going to move myself so you can just see that bottom picture there. I used to be an elite rower, as you can see. I played lacrosse every day for about 12 years. I took up a sport called capoeira on the top right. That's a Brazilian martial art. I did kung fu. That's on the bottom right there. So lots of different sports, and that's been a really big part of my life, staying fit and healthy and active. And actually, one of the things I love to do the most is high altitude mountaineering. So here are some pictures of me in the mountains. I'm in the Andes in South America, and I'm climbing mountains that no one has ever climbed before. So I found these mountains by writing some computer code for our supercomputer at the university. And I found the mountains and then went off to climb them with my friend. And the most exciting thing about this is that because these mountains have never been climbed before, we don't know what to expect. I don't know how to get there, or whether there'll be snow or ice or rock. I don't really know what the weather will be like. I don't know which route to climb the mountain until I get there. So although I do lots of planning, it's always very exciting to finally arrive and start climbing. And one time I've been climbing for a couple of months, and I came down from the mountains to a village called Fiambalá in Argentina, a tiny village, and they have free public Wi-Fi in their village square. So I opened up my computer and I had an email from the BBC saying, "Do you want to be an astronaut?" So I thought, yes, actually, that sounds like fun. I want to apply for this television series about astronaut selection called Astronauts, Do You Have What It Takes? And I think it might still be available on the BBC if you want to have a look at it. So they had 12,000 applicants. They narrowed it down to these 12. I'm the one with the bobble hat you can see in that picture. And most of us have a science background, because a really great thing to do if you want to be a scientist is be an astronaut is to be a scientist. So this is going to be a bit like the bake-off in space. So we've got a judge, Commander Chris Hadfield, a Canadian astronaut who's been to space, and he's the one that's putting us through our paces. And if we don't do very well, we might be asked to leave the show. So we start with 12 and we end with one person at the end. Here's our first challenge, to hover a helicopter for 15 minutes. Let's have a look at how we get on. There's the judge in the middle, Chris Hadfield, wearing the red. Here are the candidates having a go. Now, I've never been in a helicopter before, but that's what we're trying to do, hover it. And here is our first attempt. That person didn't do too well to start with. Chris looking disappointed. The next person is Prash. Prash is a surgeon from Birmingham. And he somehow doesn't do too well either. Look at this. The helicopter goes off to one side. He has another go. Each of us had lots of attempts to try and hover this helicopter, but we weren't very good at it. And it can be quite disappointing if you want to be good at something and you aren't. Here's my friend Hannah. Hannah's a mountaineer and a dental surgeon. Hannah put the helicopter in reverse, just reversed off the side of the screen. She wasn't very good either. And in fact, none of us were very good at this challenge. And we later found out that was the whole point. That's Prash again. They were testing our response to failure. They wanted us to fail. And they wanted to see how well we do when we fail at something. And what they want to see is someone who's positive, who keeps trying, who doesn't give up, not somebody who's negative and quits or gets angry at themselves. So this is a really interesting first challenge. How good are we at failing? Let's have a look at another challenge here. This is the next one. This is an underwater challenge. So here, we were asked to get into a capsule, put on a dry suit, and put on our seatbelt, and the capsule sinks down under the water. So now we're sitting strapped into a capsule. The capsule's going to sink under the water, and we have to escape from the capsule. So it's an escape challenge. Astronauts do a lot of training underwater, so it's also a test of how well we can swim, but also how calm we are under pressure, because you might feel a bit nervous as the capsule starts to fill with water. So how good are we at staying calm under pressure and following our instructions? So all we have to do is sit still, hold our breath, and wait until the capsule stops moving, and then we can escape from the capsule. And sometimes the capsule just flips over half a turn like that one, and sometimes it just kept on turning over and over and over. So that's our real challenge, is to figure out how not to panic and to stay calm. That was the point of that challenge. Really interesting one for us. The next one, this is an underwater challenge. Again, astronauts train underwater because it feels a lot like floating in space if you're under the water. So here we are. Had the opportunity to scuba dive to the bottom of the ocean in Florida, where there's a little house, as you can see, an astronaut training facility. And there were 3 of us left in the competition at this point. And we got down there were fish swimming past the windows, it's beautiful. We got a phone call from Commander Hadfield telling us that the carbon monoxide alarm has gone off. And so what does that mean? It means that we have to find fresh air from the surface and get it down to the capsule as quickly as we can. So we put on an oxygen mask, and that just gives us a bit of time. As you can see, we've got about 30 minutes. And there are hundreds of dials and buttons all over the inside of this facility. We have to work out which ones to press in which order to get the fresh air down to us. So this is about thinking logically and working your way through a problem-solving skills. And actually, as a scientist, that's something that we work on our entire careers long. But it's also about teamwork and leadership. So how well are we able to work together to complete our challenge? Let's have a look at the next challenge. This one is called a centrifuge. And this is going to make us feel as though we're launching in a rocket. So we get into this pod, they close it up, we put on a seatbelt, and it spins in a circle really, really, really fast. A bit like going on a fairground ride, really fast. You start to feel kind of squashed, don't you? We feel exactly the same way. And so you can see it's going faster and faster. And if you look at our faces, you'll begin to see we don't look that comfortable. This is my friend Tim, he looks a bit uncomfortable there. Watch his cheeks though, there. He's feeling this huge downward force, his face is kind of sagging downwards. He's not looking that great. But this is one of the challenges you have to undergo if you're going to go into space. You have to be able to cope with these high G-forces. And that's exactly what we were being trained to do in this challenge. There's me looking a bit unhappy. Although it was super fun. It was in fact my favourite challenge. Let's have a look at another one then. So the next challenge I'm about to show you, I think will probably be your favourite challenge of all. And in the next challenge, we are in an aeroplane, and the aeroplane flies up and down like this. And we have this opportunity to float as though we're really in space, just for about 30 seconds. So let's have a look at that. Oops. So we start off lying on the ground. We have about 30 seconds of floating inside this aircraft. As the aircraft falls, we all fall with it and we start floating around. This is our Superman shot the BBC asked us to do. That didn't end so well. So we're floating around, we're hitting the walls, we're bouncing into the ceiling, we're doing lots of somersaults. It's really hard to work out which way is up and which way is down as we're floating. And our challenge is to assemble a camera, a Polaroid camera, put the film and things in the camera, the battery in the camera, fly and take a picture of Commander Hadfield and sign our name on that picture that pops out of the camera. And as you can see, we're really struggling because if we let go of an object, it floats away. We can't get it back again. So we've got to be super careful with everything that we need, making sure we don't let go of it, making sure we don't crash into somebody else. It's really, really challenging because up becomes down and down becomes up, and you get very disorientated. So you can see I'm kind of floating around there. Each of us has just 90 seconds to complete this challenge. 3 of those loops, remember we float for 30 seconds each loop. So 3 loops, 30 seconds of floating each. That's 90 seconds to complete the challenge. This is a picture of me crashing into Commander Hadfield at the end of my challenge, bouncing off him and managing to take his photograph. This is Tim. Tim turns the camera on and off 5 times and never finds the button to take the photograph. So he gets right to the end of the challenge. But definitely one of the most fun challenges that we did. So, I've had lots of fun since the show. The show itself was fantastic, and I really, really enjoyed spending this time with my amazing friends and doing 44 challenges in total over 7 weeks. So many more challenges than you saw in the clips there. But it was really testing, really exhausting, but also really enjoyable. And actually, I ended up winning the show, which means I have a letter of recommendation now from Commander Hadfield for the next round of European astronaut selection. Since the show, I've had lots of great opportunities. I've been back to the centrifuge to fly around a bit more. That's what you can see in the bottom middle picture there. Flying around in the centrifuge, doing sea rescue, manoeuvres. There's pictures of me doing outreach, talking to lots of people all over the country about the amazing opportunities I had and about being a scientist. So I've really been busy since the show finished. But the thing I'm most excited about is I was selected for a global leadership program called Homeward Bound, which is all about thinking about who the future leaders will be when it comes to tackling the climate change crisis. And the idea is that they're going to bring together, every year they bring together 100 women. We do a year-long leadership program, just recognising the fact that women are underrepresented in the climate change debate. We're all scientists with different areas of expertise, different things to add to the story. And we do a year-long program culminating in a voyage to Antarctica, where we see the vulnerable environment, fragile environment that we would like to protect. We do scientific experiments in that region to try to understand the effects of climate change on Antarctica. And we really explore a leadership journey together. So thank you so much for listening. I hope you've enjoyed finding out a little bit more about the kind of things you can do if you want to be a scientist and maybe what it takes to be an astronaut. The one thing that I would say to each and every one of you is that all of these amazing things that you have an opportunity to do come about because you're bold and brave and you give it a go. You never give up. You don't worry about failing at things. You just keep trying and eventually you'll make it. So I would say to all of you, take every opportunity you have and just keep going. Never, ever give up. Thank you very much. Bye.
So thank you, Susie. She's not here, but it's a brilliant piece of inspiration for us. Tell us a lot about her as a person and what she's done in life, but and also someone who volunteers, someone who gives time, someone who gives different opportunities to other people, thinks about others and what she can do to help them. An amazing sort of person to hear from and learn from. I think based on that, you can see she's had to work hard, she's had to fail, she's had to learn from failure and pass on again. I think they're all good skills that we learn and we practice every day, but it's really good to hear someone who's taken that to another level, really inspiring for us. In terms of what we're doing next, we've had a number of people in this audience who've been working on space in a variety of ways over the last year, probably. And we're going to hear from some of them. I think, first of all, we should just mention First Radford Semele Scout Group, because they are hosting us today. Where are they? They're very quiet today. First Radford Semele have helped us to put this on. They are the inspiration behind this, so they are at the heart of this today. But they have kindly invited First Sydenham Scout Group, who are also here, and are noisier. Yeah. And we do have First 6 Leamington as well, who are somewhere in the background. Yay. And I've seen a variety of other neckers from the far-flung corners of Leamington District and beyond, which is good because we are possibly national and maybe even international with this experience today. So you're representing the world for this moment. So thank you very much for what we're here today. But we do have our next piece, which I think is our young people from Radford Semele are going to talk to us about what they've been doing related to space, science, technology, engineering and medicine, what they've learnt over their time with the different badge work they've been doing. So I'm going to turn to human microphone stand at this point, and the guys this side will help us talk us through what they've been up to. Okay, you can take us away.
While we were looking forward to talking with the astronauts in the ISS, we did lots of activities to help us learn about space and space travel. First, we went on a space hike, but not in outer space. It was in Radford Semele. We looked for constellations and learned about the planets in our solar system and how far away from the sun they all are. When we reached Neptune, we hiked home. When one night, we learned about food on the ISS and how the astronauts get fresh food in space. We planted seeds and tried to grow beans without soil. We took them home to look after them. Some of them are still alive. We learned about what it is like in space and made pictures with glowing paint to show what things we had learnt about, like the Milky Way and nebulae.
Very good. Well done. Okay, what have you been up to? Tell us about what your experiences are.
We went on a space-themed camp, so we were away from home like the astronauts on the ISS. We all watched a video about life on the ISS. It was fun to watch the astronauts taste water drops that were floating around and catching them in their mouths. I don't think they always drink like this. I think they have special cups.
Thank you. Thank you. We can clap. Wow.
At our meetings, we have a challenge to dock our model of progress. 93 cargo ship on our model of the International Space Station. The docking area was made from a paper cup, and we had to land our model inside the cup without knocking it over. It was hard because we were a team of 4, and none of us could touch the cup or the model of the spaceship. We just had cords to pull or lower or lighten or loosen or by talking to each other and following instructions so we didn't crash. We managed in the end, but we had a few accidents first.
So again, a good chance to learn and learn from those things and try again. Well done.
We had some meetings where we learned about skills astronauts might need to have. We learned about Morse code and secret codes to pass top secret messages. Being able to use different ways to contact each other might be important in space, where one day you might need to talk with aliens.
Wow. There you go. Setting up further. Astronauts and aliens next week. Well done. Brilliant. Thank you.
First, Radford Semele Cubs, and we have been thinking about space. We have been very excited and done lots of stuff about it. The group favourite is the planetarium trip. We went on an epic trip to Mars Observatory and we saw a massive telescope. We went into a planetarium and saw the night sky for that night. The majority thought blowing up the ball repeatedly on a huge screen was the best. We learned a lot, including how Betelgeuse is going to explode soon. We made space-themed clay models. We got creative, so there were some aliens, planets, ice cream asteroids, hang charms, and even a TARDIS. We dived deeper into taste and tasted space food. We ate freeze-dried strawberries, red currants, blackberries, peaches, black currants. Our favourite was the freeze-dried kiwi. We located a crash plane on the school field with triangulation. We had our own homemade radar and walkie-talkies. We used teamwork and Morse code. We made planispheres and then used it to stargaze. We saw Ursa Minor and the North Star. We wanted to know whether you can grow food in space. It turns out you can. We did it by putting Mizuno radish, cress, zinnia flowers, seeds on cotton wool or wet kitchen roll. Did you know in the ISS they worked out you can grow plants in lunar dust, and they grow plants in a space station in a machine called Veggie. Scientists are now developing a greenhouse to grow plants on the moon. Finally, we made a constellation viewer using a Pringles tube. We did this by cutting out our chosen constellations and then punching holes in them with pins and put it in the lid of the tub and looked through the hole in the bottom. We have really enjoyed learning about space. We've been building up to this all year and we are truly thrilled.
Wow, lots going on there. Well done. Yeah. What have you been up to? What's your name? You okay? No? Okay. So, we'll just take that one and go. So we have had quite a lot going on here. We've got a few more. We've got the Scouts coming in next. So Scouts, tell us your name and what you're up to.
I'm Julian and we learn how to make bottle rockets.
Very good.
We learned how, the more water you put in, and that's kind of the fuel of it. And the more air you put in, that's how far it goes, and the pressure.
Excellent. Someone hiding around the back there. Come forward. Let these people through. Come over there. Take a seat.
In Scouts, we learnt that space food is specially prepared to meet the unique challenges of microgravity. Astronauts consume a variety of meals, including freeze-dried, fresh fruits and vegetables.
Wow. Cool. I'm worn out just listening to what you've done there. So it's a brilliant sort of year of experiments and learnings. Anything else you want to say about Radford Semele and Sydenham? Anything else you did you enjoy yourselves? Yeah. What are you going to do next? Having had a year of space. Sounds like aliens are next. So alien search is next. So first Radford Semele and first Sydenham, you've done a huge amount. I know first six, you've also been working on space. But can we give all the young people who've come and spoken and told us about the experience a round of applause? Well done. And it's been a great opportunity to think about what space means to us and what space can offer us in terms of experiences. That link, and Susie made that point around science is such an integral part of space. It's a key skill you had. She's a physicist. She uses her experimental skills every day in terms of what she does. It's a really good opportunity to find out more about sort of the world and your part in it, and test yourself and challenge yourself. So it's been really good to see the Scouts, the Cubs, the Beavers, even the Explorers having a go at different ways of learning about themselves. And you can see some of the photos that have been coming up during the year. So plenty going on in the world of Radford Semele, Sydenham, First Six Leamington and beyond. So I think one more round of applause for all of you for all the great work you've been doing this year on space. Well done. So I'm going to bring you now to another person. This person is known as Robert. This person I know is a bee leader, as many people are, but they are superhumans who do more than one thing, which is amazing given the time they spend on bee leading and actually having time to do anything else. Robert, if you read his profile, is actually another professor of space physics, which he does bring with enthusiasm to his work in First Six Leamington. He has a variety of things on his website, what he does, but he particularly, I guess, is looking at a number of areas in space, again, quite related to space weather, but he works with the University of Southampton. He works on things like magnetic reconnection, solar winds, and global magnetosphere dynamics. So we're hopefully going to try and bring that into something that I can understand, if nobody else can understand, but it's some really good stuff. I think the key thing here is, yet again, like Susie, another volunteer gives time to others, helps other people learn and grow and develop in the world, but also is a brilliant person who can tell us lots of stuff about what they do in life. So I'm going to hand over to Robert and become his assistant at some point and see where it takes us to. Robert, the floor is yours.
Okay, thank you very much. When I wrote those words, I had no idea they'd be read out to a bunch of Scouts, but it's been great to hear all the stuff that you guys have been doing as well about different things to do with space. So, as Mark says, I do a very similar job to Susie. I don't climb as many uncharted mountains, and I've never trained to be an astronaut. But I have a slightly different favourite planet, because my favourite planet is actually Earth. And what I'm going to show you here is something that, although I'm not going to talk about the space station, this is something you can see from the space station. On the screens you can see a picture that's been taken by a European astronaut called Samantha Cristoforetti. And when she went to the space station, she took this picture from a window at the bottom of it. So you can see at the top, the white thing there is the underside of the space station. The right-hand side, you've got a bit of a solar panel. And the long thing that bends here is a robotic arm. And the curved bit you see underneath is the top of the Earth's atmosphere. So you can see the Earth is indeed round. And there's a kind of a green glow there. Does anyone know what that is at all? Yeah. The Northern Lights, yes, also called the Aurora as well. Has anyone seen the Northern Lights before? Where did you see them? Shout out some places you saw them.
From my window.
From Lapland, yeah, hearing some places north, and I'm also hearing Warwick and other places. So we'll talk. It is really unusual to see the Northern Lights around here, but it does happen, and it happened last May. This is actually a movie that I'll play, and as you see, the International Space Station is orbiting around the Earth, and it happens now to be going near the pole, the North Pole, so near the top of the planet, and that's why we see, it's close enough to see the Northern Lights. That happens near the North Pole. You can see it's very changeable. There's lots of ripples and changes in brightness. It's kind of green low down, but it's actually a bit red higher up, very bright bits there as well. Can you see bits flashing on and off here? The bright thing there is just the moon coming into view and up and above, and lots of flickering and all sorts. So the Northern Lights, you might see with your eyes. You probably, if you've seen it, it might have been quite changeable. It might have been quite static. But indeed, it's really, really very changeable, and you can see it on a really large scale as well. So that's what it looked like from the space station. This is what it looks like from the ground, for anyone who hasn't seen it. I took this picture. I was in Iceland and lucky enough to be at the right time to see the Northern Lights. And this is from the bay in Iceland, in Reykjavik. And that's what it looks like from a camera, taking a picture that lasts a few seconds. So what you see in that time is a build-up of all of that. You don't see that all at once. And then the next picture is literally a few seconds later and a few seconds after that. So you can see it really changing quite a lot. But those greens are kind of what I saw at that time. Okay, so some people mentioned they'd seen it from their window here and from Warwick and so on. So I'm going to talk a little bit about why that is. Does anyone know why we get the Northern Lights at all? Yeah?
I was thinking it's the way that the sun's lights bounce off our atmosphere.
Nearly. It's not because of the sun's light, but it is because of the sun. So I'm going to show you now again, it'll be a movie of the sun. And I've got to emphasize, you should never, ever look directly at the sun. You will damage your eyes very badly. But we have very special cameras, sometimes on satellites, sometimes on the ground, that will take pictures of the sun. And by taking it in a very, very specific color here, we've been able to take a picture. This is actually from a satellite, a NASA satellite called Solar Dynamics Observatory. Take a picture of the sun and all of its structure. So you see it's actually, for a start, a lot more interesting than you think of when you just draw a yellow circle. To give you a bit of scale, this little dot in the top that you might be able to see here is the size that the Earth would be if it's there. So would anyone like to guess how many planet Earths you could fit inside the sun? Yeah.
250.
Bigger than 250, yeah.
3,000.
Bigger than 3,000, yeah.
7,500.
I'll tell you what, I'll cut to the chase. It's over 1 million, okay? So the sun is absolutely huge. But look at the size of the Earth compared with all of this stuff here. And that interesting stuff on the front there is why we got the Northern Lights down here in Warwick and Leamington, and indeed further south. I work in Southampton, it was seen down there, and other places. So as I play this is again a bit sped up, but you can see, for a start on the side, all those wispy bits, that is the start of what's called the solar wind. The sun's a very hot ball of gas, so hot it becomes what's called a plasma. That flows through the solar system, it's called the solar wind. And you see really flashy bits. The flashes are flares from the sun that gives off a lot of light in these flashes, and linked with that as well, again, there's a lot of this very hot gas being given off. Okay, and so that particular set of that movie was from May last year, and a short while later, we saw the Northern Lights down here, and the reason is because here's another little sketch to show how the sun links to the Earth. This isn't to scale. If the sun was really that size, the Earth would be way off to the side. But the sun is always giving off all of this very hot gas, and then that hits the region of space around the Earth. And does anyone know what do you think the blue thing looks like? Yeah? It is indeed. I'm very impressed. It is the magnetic field of the Earth. And that kind of protects us a bit from the solar wind, but it also means that it kind of funnels these particles to the regions around the pole, the stuff to do with the solar wind. And that's why we see the Northern Lights. These are pictures not from Lapland and so on, from down the road somewhere here in Warwickshire. And then on the bottom left, that's from Norfolk, so kind of same latitude as us, just a bit further east. And the ones on the right are from down the south coast of England. And so that's the aurora that we saw, the Northern Lights, also called the aurora, that we saw last year. And so to understand the reason why we could see it here, we need to think about what it looks like from when really high up. So you've seen what it looks like from the ground. You've seen what it looks like from the space station that is literally just above it. If you have a satellite that's a very, very long way above, you can get pictures like the one on the left. That's real movie from a satellite called Image. It was a NASA satellite a few years ago. On the right, it's a simulation. It shows you get the northern lights, but also lights around the South Pole, the southern lights. In fact, these are the southern lights here. The white mass you might see in the middle is Antarctica. And what shape does the aurora, the southern lights, look like to you? Yep. It is a circle. So that's why, so for a start, if you want to see the northern lights, you don't want to go to the North Pole itself because you'd be too far north. So it forms a ring, and it helps us understand why we get the northern lights here. Because someone has mentioned the magnets, magnetic field. You might have played with a magnet at school. You might know they line up north to south and they attract to the others. And you might have done this thing on the right where you sprinkle iron filings, little bits of metal around it. And so the metal then lines up and it traces out what's called this magnetic field line. And that field is why your compass, when you're navigating, points north, because the Earth itself is a big magnet. So your compass will point north. We just have to flip things upside down to get it kind of just right. But your compass points to the North Pole. Also then, the solar wind kind of gets funneled down and it forms these northern lights and southern lights near the pole. To understand why, so normally that's kind of going through countries like Greenland, Iceland, Norway, Sweden, and so on. But to understand why it comes down this far south, I'm going to do a little demonstration. I'm going to need a bit of help. Can I have maybe a beaver and a cub who knows some countries and is able to recognise some countries from the world? So, okay, do you want to come up? And we have a cub who, do you want to come up? About recognising countries. We'll have a bit of help with Mark as well. So, can I ask you please to come around? Sorry, what's your name? Lily, if you stand just in front of me here, and can you hold the globe? If you stand side on, actually you're going to need to come closer. How about if you stand in front of this camera here? Can you just come around here? Can you come around here and hold this? And your job, sorry, what's your name? Cedric. You've got a special job. You've got a hairband here, a scrunchie, that I'd like you to put on top, and that's going to represent the Northern Lights. And if I move on the slide, we can hopefully see, here we go, courtesy of Mark's cameraman duties. Can you point out, one of you, if I hold this, or if Lily can hold that, Cedric, can you point to the North Pole? Can you see where the North Pole is? It's there, yeah. And if we look around, can you see the kind of countries that underneath this scrunchie? Can you name, where's this, do you think? Do you know these?
South Pole.
The South Pole's down at the bottom. Do you know what country's up here?
America.
Yeah, that's Canada, and we've got, do you know that one? Iceland. And around here we've got other countries where you might see the Northern Lights. So now, if Lily can hold that, and Cedric, can you stretch the scrunchie? And if Mark catches this on camera, if we stretch it, what happens to it? What are the countries, where are the countries it's now on top of?
Canada.
Say again, sorry?
Canada.
Canada, it's gone a bit further down. What about over here? Or Lily, do you know where that is?
Europe.
Europe, and down to the UK as well. So if we maybe bring this a bit along there, you can hopefully see as that scrunchie gets bigger, it comes down to countries a bit further down. And that's what happened. Thank you very much. If I take that back, thank you both. If you want to head back, and thanks, Mark. Round of applause for our volunteers there. That's why we get the Northern Lights further down, is because the Northern Lights acts like that scrunchie. Sometimes the ring gets bigger, and when it gets bigger, it comes down to us, and that's why some of you were able to see the Northern Lights here last year. Okay, so the final thing I just want to say is that part of the reason we study this, people like Susie and I study this, is to understand how that all works. But part of the reason that Susie also mentioned is that the same things that are causing the northern lights also have effects on technology, both up in space, like satellites, and also down on the ground, like power grids or communications and things like that. And as we have more and more technology nowadays, it's becoming more and more important to understand and predict what's going to happen. You might have heard of companies and organisations like the Met Office who do our weather forecasts. For the last few years as well, the Met Office has started doing space weather forecasts to help companies that operate aircraft, satellites, power grids understand what's going to happen and know what steps to take to look after their equipment. Okay, so it might well be in years to come. We have students going off to go and do space weather forecasting at the Met Office and the like. It might well be in the years to come. We'll be tuning some of you guys giving those kind of forecasts. Okay, so with that, I'll return to the picture, and thank you very much.
Robert, thank you. So some really interesting things there, lots to think about. I'm going to keep us pressing on because we have to bring Kieran to the stage now. Kieran is the operations lead for the ARISS group, but also works with the Radio Society of Great Britain. He is the man who's going to help us get through this next piece. You need a professional to do this, someone who's done it many times, and we're in very safe hands with Kieran. Kieran is going to take over and run us through. We are about to get to that point. The people we're waiting for are talking to an astronaut. Are we excited? Yeah. That's mildly excited. Are we excited? Yeah! Kieran, are you ready? Okay, well, we'll just give him a moment just to get himself into place. But broadly, we are very close now. We're going to just have a bit of a run-in. We have to sort of link this up exactly to when we need to talk to the station. That's why we have this team all over the place trying to keep this in control. But Kieran, the floor is yours. Thank you very much.
Hi everyone, I'm Tim Peake and welcome aboard the International Space Station, where we're orbiting Earth 16 times every day. One of the most rewarding activities that some astronauts undertake on orbit is to talk to schools using the space station's ham radio. Now these are events that are planned by ARISS, which is a worldwide group of amateur radio volunteers who are dedicated to introducing young people and students to science, technology, engineering and mathematics.
So good morning everybody. Morning. Oh, I'm just checking to see if we've got audio in the room. Hello. To your contact with the International Space Station. So today we're going to run through a number of things and then a little talk about science, technology, engineering and mathematics that Tim mentioned there a few minutes ago. But today we're going to be using a little bit of language that I want to run through with you so that you understand it. Anybody heard of the phonetic alphabet? Yeah? Who knows how to say the name at the top in the phonetic alphabet? Yeah, go for it. Sierra, Sierra. That's right. So one of the things that we have to do whenever we're on air is that we have to identify ourselves. And the space station identifies itself as NA1SS, or November Alpha 1 Sierra Sierra. Today we're operating as GB4RSS. So in the proper phonetic alphabet, that's Golf Bravo 4, Romeo Sierra Sierra. But can anyone have a guess what I made the RSS also stand for today? Yeah? No, not quite. Not quite.
Radford Semele Station.
Almost.
Radford Semele Scouts.
Perfect. You got it. So a little bit of special meaning for us today in terms of what we're doing with the Leamington District Scouts. So one of the things that I want to do, just a few messages as well. Can I just check and make sure that anybody who's got a mobile phone, can you make sure it's either turned off or turned to silent, please? We don't want any interference whenever we're actually carrying out the contact with Tim himself, with Johnny himself, and we want to make sure we don't get any interruptions. So either to silent or switch off, please. Now, one of the things that we do with the astronaut is that we only get 10 minutes to talk to him, so we have to be really quick, and we talked about this earlier on this morning, about having to be really precise and say what we have to say really quickly. And hopefully Johnny will be just as equally quick with his answers. But one of the things that we like to do at the end of the contact is to say a thank you to him. And the best way we can say a thank you is to actually give him a big cheer. So one of the things I want to do is to practice giving the astronaut a cheer today. So I'm going to count you down from 3 to 0, and I want to see how loud you can cheer. So are you ready? Yeah. Okay, so 3, 2, 1. Okay, now I've got my guys up on the stage here, and both of them are wearing headphones, and we need to be able to make sure that they can hear it as well. So, Carlos and Dave, how was that? No, no good. So we need to raise it a little bit higher. So you're ready again? 3, 2, 1. I think you can do better than that. So stamp your feet, clap your hands, cheer as well. So are you ready? 3, 2, 1. Just about. We'll go with that one. So when the time comes, I'm going to ask you all to cheer and give Johnny some thanks for taking his time out of his day today. And hopefully we will let him know just how well appreciated he is with how the contact is going. So as I've said a couple of times already, we're talking to NASA astronaut Johnny Kim. He's in his early 40s, and he was selected to be an astronaut in 2017, which is not all that long ago, but it has taken several years' worth of training and practicing for his mission. This is his first space flight, and he flew to space on a Soyuz rocket, so just like Tim flew on his mission whenever he went up in 2015, 2016, and is currently a flight engineer. But he's also a really talented person. Does anybody have a guess what other qualifications he has? Yeah? He is a doctor, yes, indeed. Is he like? He is from the Navy as well. So he's a very talented bloke and a very good person to actually speak to. So we're hoping for some really good questions and some really good answers from Johnny today. But the nice thing about Johnny is that he has been selected as one of the potential 17 astronauts to become some of the first moonwalkers since the 1960s. So he's a really special astronaut, and we're looking forward to talking to him today. Now, you heard Tim mention it, STEM, and we've heard STEM mentioned this morning already as well. And I've got up on the screen here the meaning of what the STEM actually stands for. Anybody here do science and technology at school? Oh, good number. What about mathematics? Most of you. Okay, that's good. Well, we're going to go through each of those shortly, and I'm going to get you to do a little bit of talking about it. But science, how does science involve space? Yes, they do. They study a lot of things that come back from space, or they send space missions out to asteroids and comets and actually collect regolith and bring it back so that the scientists can see what sort of materials and minerals are on these comets and everything. And of course, the comets all in the past helped form the different planets that and especially Earth that we now live on. But more importantly, one of the big science things that's needed is rocket science, and that's needed in order to get there, because there's only one way to get to space, which is through a big rocket. Anybody give me an example of some rockets? I've mentioned one before. Yep. That's all right. It happens. Don't worry. We've mentioned the Soyuz. Sorry? Oh, okay. We've mentioned the Soyuz, but does anybody remember the Apollo? Apollo 11, yeah. Apollo 11 famously went to the moon, yeah. Voyager 2 is a space mission, that's right. But anybody remember the space shuttle? Or heard of the space shuttle? Yeah, you've heard of it. So, as you can see, we need rockets to get to space. That's the only way to get to space. We've talked a little bit about what you've studied for food science as well, in terms of special foods for space, and to make sure that things like crumbs, and you've heard Susie talk about things like crumbs, don't block up the equipment on the space station. And of course, all the scientists on the space station are carrying out physics, chemistry, and biology type experiments. Who does physics, chemistry, or biology at school? Okay, are you guys mostly secondary schools then? Yeah? Okay. So, very important for science itself, or for studying space itself. But those are some of the specialities that the research is done on the space station. But importantly, as we've mentioned rockets, the only other way to get information to the space station is through radios. And the space station is in constant contact with radios all around the world. And what we're doing today is we're setting up a radio station, a satellite ground station, and we're going to talk to the space station. Now, if I show you a picture, so that's a map of the Earth at the moment that's been flattened out, and you can see the little yellow and red line that sort of squiggles around the Earth. Can anyone have a guess what the big circle represents? Yep, but more specifically, the big circle around it.
The radio range from it?
Spot on. That's what I was looking for. That's what we call the line of sight. So when you're high up, just as Robert was showing with the camera, when you're high up, you get to see more of the Earth's space itself. And that circle is approximately 5,000 kilometers wide. And we're going to make use of that today to actually make contact with the space station. So if it's the area of radio contact, what happens whenever that circle crosses the United Kingdom?
The satellites on the ground that can communicate with it.
Yeah.
Will pick the signal up.
That's right. So the radio waves travel in straight lines, and what we're going to do is, when that circle crosses the United Kingdom, that's going to be our signal to actually start talking to the astronaut himself. I'll come back to that map later on whenever we're ready for it. So we've talked a little bit about radio science. Who's seen the big aerial outside? Yeah, is there an aerial? Well, okay, so what we have is a whole load of radios. But in order to get the signal from the radio up into the airwaves, up to the space station, we need a special thing called an antenna or an aerial. And that is basically something. Have a look. Whenever we're finished today, make sure you have a look. It's just to the left of the tent here today. But it is very tall and has got lots of pointy out things on it.
Is it the thing that helps you watch telly?
Yes, exactly the same sort of thing. Yes, exactly the same sort of thing. So have a look at it today, and we have those antennas on a very big tower today so that the antennas are high above the horizon, so that we have a good, what we call, line of sight of the horizon. So the space station will be coming in from the west from where we are, which is over in our right direction, or my right direction today, and it will be flying roughly over the south of us and then going out towards the east. Yeah? Sorry? Okay. So we've had a little bit of science. Technology. So technology, so the T in the STEM, is basically the things that we create from the science that we have done. And they're the building blocks of what we need to do, the special research and everything else that we do in space. And you've got many examples of technology on display here today. So you've got all the radio equipment, which is up on the stage, which Dave and Carlos will be operating later on in order to help us talk to the space station. You've got all the audiovisual equipment at the back, which John and the Eclipse teams are working in order to make us hear what's going on. And we've also got the video people who are recording this contact and actually sending it out live to the internet, and also to places like the space centres themselves. So NASA, who are very interested in what we do and how we do it, will potentially be watching what's going on today here at Radford's at Warwick, to see how the contact goes and how the interaction with the astronaut goes. But technology doesn't come about just because it happens. It happens because we experiment. And one of the things about experiments is that they can sometimes go wrong. And what we're doing today is a massive experiment. We are experimenting with all the radio science and equipment and technology behind us, all the audiovisual equipment that's at the back of the room, and we are working to actually make contact with the space station, who are doing their own experiment to actually talk to us and take time out of their day to talk to us. But one of the other things that they're doing today for us is hopefully something that we call ham TV, which means that we're potentially going to get live television from the space station as we're talking to the astronaut. So one of the things that will happen is that if we manage to receive ham TV successfully, is that I will ask Johnny to give us a wave. So you will be able to see him respond to me calling out and actually asking him to do something. So did I have many of you here seen the Tim Peake contacts? Or you heard of Tim Peake? Okay. We did some television with Tim Peake went back in 2016, and unfortunately we haven't been able to do any since not that far after that, because of some problems with the equipment, which is why it's called an experiment. Now, who knows what the engineering side of STEM stands for? Yep. Okay, don't worry. So engineering, in my mind, is something that basically takes all the science and the technology that we have developed and created or invented and turns it into a practical, real thing that we're actually doing. So there's a lot of engineering going on here today. I've talked about the radios being a lot of science and technology, but it's also a lot of radio engineering, how to connect all the radios together to make them fit and work properly together so that we know that whenever we press the button that we are going to get a successful contact. Go on then. Good boy. Well done. So engineering is a big discipline that encompasses all of science and technology to make things actually work. And we've got many examples of engineers here today. All my team are engineers in one way, shape, form or another, and we're always happy to answer questions. So if you do have any questions, don't be afraid to come up to us and ask us, and we will do our best to answer them for you. Now, mathematics, the last of the letters of M, is a big subject. Who studies mathematics at schools? Oh, I think that's just about everybody, which is good. Who enjoys solving problems? That's even better. Nice to see. Who enjoys solving mathematical problems? Okay, not quite so many. The way I look at mathematics is that it's essentially a glue that holds science, technology, and engineering together. It's all the special things that go together that link what each and every one of them and turn them into a discipline in its own right. Okay. And it's also something that allows us to achieve amazing feats. The mathematics, how many people think there's no mathematics involved with getting into space? Ooh, okay, a couple of hands. Who of you have heard of this lady, Katherine Johnson? Yeah. And have you seen the film Hidden Figures? Yeah. So in the days before computers, real people actually did all the calculations to actually work out how to get a rocket off the ground, how to actually get it into orbit, and once it's in orbit, how to actually keep it in orbit and then finally get it back to Earth. And this little slide is a very nice little one that I find on the internet, which basically shows all the work, all the mathematics that are needed to stretch from the Earth to the Moon to allow the astronauts to get from the Earth to the Moon itself. And mathematics is a really special foundation skill that you should actually stick with and enjoy. Oops. So we are 8 minutes? Yep, 8 minutes away from the space station. So does anybody have any questions? Okay, I'll go with you first.
I forgot.
That's okay, don't worry. Go on then.
How long would it take if you were to, from now, to get into your rocket at the docking place?
Okay, so that's a good question. To get from Earth to the space station itself, can take up to, it can happen within 6 hours, or it can take a couple of days. But the biggest part of the work is actually the rocket getting off the ground and into orbit, so that it is actually going around the Earth. And that takes about 8 minutes. So it's 8 minutes of very, very fast travel. How fast do you think the rocket has to go in order to get into space?
As fast as a plane goes to take off the ground.
Oh, it has to go really, really faster than that. So planes are usually traveling at about 400, 500, 600 miles an hour. The space station or rockets have got to travel at 17,500 miles an hour in order to get into space. And that's why they're so big and have so much fuel in them.
How would they dock? So how long does it take to get the rocket into the docking station?
So docking takes probably the best part of an hour or so once they're in the vicinity of the space station. So they have to go round the Earth to begin with, and then they have to raise their orbit so that they're at the same height as the space station. Once they're at the same height as the space station, they can start going closer and closer to the space station. And it's always done on a very slow basis in order to be safe and secure the whole time. But once they're close to the space station, docking usually takes about an hour and a half itself to get there. Okay?
How long does it take for the space station to go all the way around the world?
That's another good question. Now, if you were here about an hour and a half ago, you would have seen my team actually huddled around the radios and at the back around the ham TV equipment. But the space station takes about 96 minutes to go around the Earth. So we last saw it at about 9:15 this morning. Okay, so coming up at about 10 to 11 is when the next time we'll see it. Okay? Yep.
Do you have pizza parties on that?
Sorry, do we have? I don't know, but one of the questions is about what food do you eat in space, so we can ask the astronaut to see what he comes up with. Okay? Yep. Okay.
Can you watch TV?
Yes, you can. The space station, would you believe, it actually has the internet as well. So the astronauts basically work Monday to Friday on science experiments. On Saturdays, they have what's called station upkeeping. So they look after the station, they tidy it up, they clean it up. And then on Sundays, they have free time. And very often what they do is they watch films or talk to their own families in their free time. But they can also watch television that comes up via the internet. Okay? Hang on.
How do they get presents?
Presents.
How do they get presents? Oh, how do you think anything gets up to the space station? By the rockets. So it has to go via the rockets. Okay, over there.
Do you have any? I forgot.
Oh, go here.
How many years ago was the first rocket launched?
Oh, that's a good question. People have been experimenting with rockets for a very long time, and it goes right back to the early part of the 3 minutes, okay. Goes back to the early part of the 20th century, so a very long time. But even before that, lots of civilizations were using rockets for decorations and fireworks and everything. They are indeed. Okay, last question.
How dark is it in space?
Oh, that's a very good question. Very dark. But again, let's see if we can find out from Johnny himself. Now, something else that I wanted to do is that before, when we're starting to get ready, which we will do in a couple of minutes, we're going to hear a noise from the radio, and I just want to let everyone hear that noise now so that they're accustomed to it. So this is us listening to the radio waves and space. Now, I said that that circle, if you remember that circle, was 5,000 kilometres wide. It'll be roughly 2,500 kilometres away from us, or the space station will be 2,500 kilometres away from us whenever the time comes to talk to the space station. So the signal is going to be really quiet. So one of the things we have to do is keep really quiet. But what I want you to do is that if you start to hear the astronaut's voice, I want you to raise your hand to see who can hear it the first. Okay? It'll start off very, very quiet, but then hopefully get a bit stronger itself as well. Okay, so what we're going to do now, I'm going to talk to the guys that are doing the questions. Are you all ready? That's good. Have you got your questions ready? Okay, and you remember the practices that we've done with it? Okay, so what we're going to do is we're going to get you to stand up and get ready in line for the contact themselves. Yeah. And remember, it's really important to stay in the same order that you've got your numbers on your questions. But also, what's really important to say at the end of your question? Over. That's the signal for us to switch between the transmitting to the astronaut and receiving from the astronaut, okay? So, let me just check on how we're doing. Okay, so we're going to start calling, and let's see how well we get on with the astronaut. November Alpha 1 Sierra Sierra, November Alpha 1 Sierra Sierra. This is Golf Bravo 4 Romeo Sierra Sierra, standing by for a scheduled contact with the International Space Station. Over. NA1SS, NA1SS. Over. NA1SS, NA1SS, this is GB4 Romeo Sierra Sierra, standing by for a scheduled contact with the International Space Station. Over. NA1SS, NA1SS, this is GB4RSS. We have you in the noise, Johnny, so hopefully you will... Over.
Yes, sir, over.
Go.
Hi, I'm Leo. Is being on the ISS like living on Mars? Over.
You know, I don't quite know for sure, but I suspect it is. Living on the space station is like taking a really long camping trip. We are in an austere condition, just like camping would be. And I think being on Mars would be just like having an expedition on the United States.
This is Robin. Can you see the Milky Way from there? Over.
Yes, we can see the Milky Way from here. It's so beautiful. Everything that you can see on Earth, we can see from the International Space Station, but a lot more clear because we have a lot less pollution and atmosphere noise. Over.
Hi, this is Oscar. Do plants still grow towards the sun on the ISS? Over.
Hi, Oscar. Plants grow towards their nearest light source, and so that's not always towards the sun. In the International Space Station, it might be the nearest light bulb. Over.
Hi, I am Alice. What's the funniest thing that's ever happened to you in space? Over.
Oh my gosh, there are so many funny things that have happened to me. I think most of it has been funny pranks that my friends, my crewmates have done for me, like sneaking up behind me. Over.
This is Ruben. What happens if you drop something in space? Does it just float forever? Over.
Right now I've got nuggies for my kids, and I'm dropping them in space, and they will keep floating forever. Over.
This is Eric. Have you ever seen a space bomb or shooting stuff from the ISS? Over.
Eric, I've seen a lot of storms and shooting stars. Sometimes they happen so quickly that I don't even notice it unless I'm actually taking pictures, and then I review the pictures later. Over.
Hello, this is Eddie. Have you ever had to fix something important in space, and what happened? Over.
On the International Space Station as astronauts, not only do we perform science experiments, but we are also constantly fixing things. I'd say one of the most important things I've had to fix was the toilet, because that is very, very important. Over.
Hello, this is Felix. Do you ever play tricks or jokes on each other in space? Over.
Oh, yes, we play lots of jokes on each other. One time, I had my friends were hiding inside a big box, and I didn't know it until I went near it, and they popped out and surprised me. Over.
NA1SS, Johnny, we have you on Ham TV. Thank you very much for activating it, and I'd like to dedicate it to our colleague Gaston Bertels, who worked so hard to get it in space. So give us a wave, please.
What do you eat for breakfast in space? Cereal would float away.
Over.
Over.
Okay, I think the last question was, do I ever play tricks and jokes on each other? We do all the time, and because Halloween's coming up, I'm really looking forward to that. Over.
What do you eat for breakfast in space? Cereal would float away. Over.
I had breakfast. I had a tortilla and some breakfast sausages, and yes, cereal would float away if we let it. Over.
This is Sasha. How does a spacewalk feel? Over.
Hi, Sasha. I have not performed a spacewalk myself, but I have supported one, and talking to my friends who have done one, they're really hard, but we've trained a lot on the ground at NASA so that we're well prepared. Over.
Hi, this is Millie. Does food taste different in space? Better or worse? Over.
Hi, Lily. Food tastes different. It's just not as strong, which is why I use a lot more hot sauce and salt than I normally would on Earth. Over.
Hi, I'm Cohen. What is the coolest experiment you have done in space? Over.
The coolest experiment I've done in space is an experiment where we tried to see if we can grow more perfect crystals in microgravity. And the reason we're trying to do that is because it might make medicine stronger. And if we can do that, it'll help a lot of people on Earth. Over.
Hi, this is Alyssa. Do you feel dizzy when you get back to Earth? Over.
Yes, we feel very dizzy, and that's because our bodies get used to having no gravity. When we return, all of the senses come back, and our brain gets very confused. Over.
Hello, this is Lily. With Halloween coming up, do you hear creepy sounds on the ISS? Over.
The space station can be quite creepy. Space is very quiet, so it's easy to sneak up on each other. So I suspect a lot of creepy sounds will be coming near Halloween. Over.
Hello, this is Freddie. Do you play board games on the ISS? Which ones? Over.
Yes, we play board games. Actually, we played one last weekend, and we were playing Codenames, which is a fun, team-based game on trying to think of the other person's word. Over.
Hello, this is Lucas. What's the most difficult challenge you've faced while living on the space station? Over.
The greatest challenge I've had is missing my family. I have two little stuffed animals here, and they belong to my two youngest kids, and I miss them very much. Over.
Hello, this is Dylan. Do you have bedtime stories or teddy bears in space? Over.
Hello. Yes, we do have teddy bears in space. I've got my daughter's little dolphin here and my son's little lion right here in space. Hopefully you can see it. Over.
This is Cynthia. How many months can you stay in space for? Over.
Sure, you can stay in space for as long as you wanted to. My mission is 8 months, and I've been up here for a little over 6 months. Over.
Hello, this is Mahika. How do you prepare your body and mind to live in space for so long? Over.
You know, just like with a lot of hard things, it requires a lot of focus, training, preparation, and good support network. I would say I've had a lot of help along the way with not just my family, but also my friends and the people I'm up here with. Over.
Hi, I'm Ethan, and can you drink hot chocolate in space? Over.
Yes, we can. It's one of my favorite things to drink, especially when it feels a little cool up here. Over.
This is Sihath. How do you stay clean without a shower in space? Over.
So we don't have running water in space, and shower is one of the first things I want to do when I return to Earth. But we do clean ourselves, and the way we do that is we get a towel and we wet it with some water and we rub it around against our body. It's kind of like a scrub bath. Over.
Hello, this is Sophia. What training do you have to do to be an astronaut? Over.
You know, there's a lot of training, language training, flight training, learning how to use the spacesuit, learning the engineering. But I would say the most important thing to being an astronaut or just successful in life is just having a curiosity to learn. You're never too old to learn something new. And if you remember that, you can do anything that you put your mind to. Over.
NA1SS, NA1SS, this is GB4RSS. Johnny, thank you very much. That was absolutely fantastic, and thank you for all your efforts to get Ham TV operational for us. Everyone here wants to say a big thank you. So, you ready? 3, 2, 1. NA1SS, NA1SS, this is GB4RSS. Thank you very much, Johnny. I hope you've enjoyed the contact today. We certainly have, and we look forward to hearing from you soon again. This is GB4RSS signing off and clear. NA1SS. NA1SS, NA1SS, off and clear. Thanks very much, Johnny.
You're very welcome. NA1SS out.
Okay, so you guys can all sit down. So you've just completed your own little bit of history today, because you've made contact with Johnny Kim on the International Space Station, and we've been able to ask him 22 questions, which is amazing. That's more than we've ever done before, so well done everybody again. Okay, now you've seen us working the Ham TV. We had successful pictures, and we got some pictures from Johnny today from the space station. That's the first time since 2018 we've been able to make that experiment work. So a big thank you to all the people who have laboured to make that work, both on Earth and in space. So I think a big round of applause to them as well, please. Okay, so I think with that, I'll say thank you very much. ARISS is an international volunteer organisation, so we do all this for free for everybody, and we look forward to seeing you all grow up and do some exciting STEM activities. So thank you very much, everybody.
Was that amazing or what? Yes! Can we just say thank you to Kieran? That was amazing. Well done, Kieran. Oh. I'm worn out just watching. That was amazing. Thank you so much for well done questions. Question answers. Really good questions. No more questions at the moment. Brilliant. So we have some thank yous. We remember those sponsors. Those sponsors that made this possible. There's been an immense amount of work getting to this point, but it starts with the amazing ARISS in all their forms of audio, visual, radio, and plugging things in and making things work. There's been so much going on. Can we have a really big cheer for the ARISS team, please? And of course, Jaguar Land Rover and also Leamington Roundtable, their work and their support for us meant we could be here today. So can we thank you, both Jaguar Land Rover and Leamington Roundtable. Hatton Adventure World, it's been amazing being here. Thank you for hosting us and for putting us on. Thank you. And Hatton Adventure World, you have an option. If you've been here today, they are offering discounted tickets to go in. You have to sneak up to the counter and whisper the word Scout SIS or ISS, and they let you in with a discount. So the day is yet young. So make the most of the day while you're here. And then finally, the last one we sort of talked through was Eclipse. Eclipse have provided a lot of audiovisual equipment for us, both here and on other sites. They're enabling us to talk to a variety of people all over the place. We seem to be local, national and global, and possibly even out of space. So we've been everywhere today. So Eclipse and all the work they've done, thank you so much for all you've done. We've had some amazing presenters today who've, I guess, really inspired us from all ages here, both people who do it for a job and people who are doing it as part of a scouting activity. But well done to our presenters, first of all from Radford Semele and Sydenham. So our amazing questioners and questions raised some really good questions, some thought-provoking stuff. Well done. I think we had a really inspiring talk from Susie, who's not here, but we can, again, thank her once more for she did everything. And of course, our very own Robert, our own professor from First 6 Leamington. Thank you, Robert. I thank most people. There's one person we haven't thanked yet, and he will hide in the background for as long as he likes. He can go to the corner now. But Gavin has done an immense amount. So Gavin about a year ago came up with this idea of talking to the International Space Station, and if you want any inspiration for how you can make something you want to happen, Gavin is a great example of that. Gavin has ploughed away relentlessly over infinite obstacles to get to today, and I think he's created an amazing experience for us, but for all the people watching us as well. It's been brilliant. So thank you, Gavin, and also thank you, Eclipse, for letting him spend so much of his life doing this as well in his spare time. So thank you, Gavin. Now, the reason you have me here is I like talking and Gavin doesn't. And Gavin said one thing very clearly I was not to do, was to bring him up the front because he likes to stand behind the background. But being a good person like that, I'm going to break that rule because I'm going to ask Gavin to come up. And the reason I need to ask Gavin to come up is I have the opportunity as a lead volunteer in Leamington District to I guess, recognise people who've done great things. And if there was a great thing that I think has been here for all of us and for, I guess, the people we're inspiring and motivating today, I have an opportunity to give something called a Commendation Award, which is an award that recognises the amazing idea you've had and how you've turned that into an incredible occasion, enabling all these young people here and beyond to take part in a talk with the astronauts on the International Space Station. So this is for you, Gavin. Wear it with pride. Thank you from behalf of Leamington District and Scouts for all the great work you've done.
Thank you very much.
Thank you.
Thank you.
Okay.
Of course, I couldn't have done it without everyone, so thank you very much.
That was a humility there. He thanked you all for all you've done. So again, thank you. Thank you for all the leaders and all the volunteers and all the young people who made this event today successful. We are now at a close and we can go and sit down quietly somewhere. We now have to get you safely from this building. So this will happen in a sequence and order, and it will start by group standing up and moving calmly towards an exit.